This is chapter number 4, which is algorithms and flowcharts of your A-level IT. In this lesson, we are going to discuss about four different areas, which is editing a given algorithm, writing an algorithm using pseudocode to a given problem, editing a given flowchart, and drawing a flowchart to solve a given problem. So, first of all, do you know that what is algorithm? Mhm. Do you have any idea what is an algorithm?
Like I I don't know. So
Basically, algorithm, you can say that algorithms are basically a series of steps, a sequence of steps that are used to complete a specific solution to a problem. An algorithm is a series of steps that are followed. And these series of steps can also be implemented in your daily life. Like there are some areas of our life that are you know, that are only considered as a series of steps, such as your daily routine or something that is being done on daily basis. Like, for example, when you wake up in the morning, you go to school, and then there you have your complete routine. This is some series of steps, right? Which is an example of an algorithm. Similarly, if you are making a cup of tea as well, that is also an algorithm in the sense that when you are making a cup of tea, this is an example of series of steps. And what are the series of steps associated with that? Like the first series of steps is that, like to make a cup of tea, you pour in the water, you heat the water until a certain temperature, then you put the tea bag or something, then you add sugar, then you add milk. So you have some sequence of steps. So whenever you have a sequence of steps or series of steps, that is known as an algorithm. In this chapter, we are going to discuss how to develop algorithms to solve problems in a form that a computer could follow. So all computer programs are simply a series of algorithms that are written in a specific way that the computer processor can then follow at a time. So you follow a lot of algorithms without even realizing. Like I just told you that either if you are making a cup of tea or even if you are following a recipe or a list of instructions. So that is also like you are following an algorithm because both of them are the examples of the algorithm. So before you write an algorithm on a computer, you can design them using a flowchart or a pseudocode. So algorithm is basically a sequence of steps. And to design an algorithm, you use two areas. One area is known as the flowchart, the other area is known as a pseudocode. So if I'm going to discuss both of them, which comes under the category of an algorithm, so you can use flowcharts. So flowcharts are basically known as the diagrammatical representation of your algorithm. Like it has boxes, it has shapes, which is easily understandable to anyone who don't have any knowledge about the algorithms or coding, because flowcharts are itself explainable. Let me show you, like right here, you can see an example of a flowchart like this. Have you seen something like this maybe into malls, maybe representing the map of the location, or maybe if you
yes,
have seen
sir.
it somewhere else, right? So you can actually see that how the things are going from one end to another. So it is quite easily understandable. But the point is that when you are creating the algorithm, so the algorithm might not be understandable by each and everyone because there are programming languages associated with an algorithm. So it's like uh, if you want to make it understand to someone who is actually not from a programming background, so you can like someone who is not associated from a programming background, so you can use instead a pseudocode or a flowchart. So with pseudocode, it is actually a language that is used to display an algorithm. Like for example, if you are working in a company and they ask you to write an algorithm, so an algorithm is going to compromise of different programming languages. Someone can say that, Mr. I know Python, I know Java, I know Visual Basics, programming language like this, but there is one programming language that is common between all of the programming languages, or you can say that even before we complete any programming language, any piece of code, one language has to be completed, that is the pseudocode. So, pseudocode is known as a language that is being used to display an algorithm. And what's so special about pseudocode is that it has a general criteria of how to write the code. It has no rocket science. It has no difficulty. It has no difficult jargons, right? Like if you are going to tell someone, so you can actually see that what is happening in the program, but comparatively, a pseudocode with a flowchart, you can see that it might get sometimes difficult when we are working with the pseudocode because it has some little concepts of the programming associated. I would not say that too complex programming because it is not a programming language. Pseudocode is just a way. It's just a language that you display your algorithm to everyone so that it's quite understandable by everyone in your team. So let it be if someone is a Java developer, Python developer, any other developer, they are all developers agree on one point, that is pseudocode, because pseudocode is the concept. But somehow, even if you still have members into your team which do not have any knowledge about programming and you still want to work with them, so you can basically use a flow chart because a flow chart is easily understandable. You can put together commands that can be used to solve the problem like this. So, are you getting my what I'm trying to tell you?
Yes, sir.
So, pseudocode simply do not have a simple syntax, as I told you. So it does not even have a set format, but it is more like a structured English. Like a simple form of an algorithm is a series of steps to move someone through a maze. So the instruction you can use it is FD5, which means you move forward 5 space. It is BK2, which means move backward 2 space. RT90, which means turn right 90 degrees. LT means turn left 90 degrees. So you can start in the space labeled start in the maze facing to the right. So see, that's how it worked. Like with those instructions, it go from here, then it went from here, then it went from here, and then here, like this. See, this is an example of an algorithm. After that, to get to finish, you would need the following steps. So, for example, we have FD7, RT90, FT6, then LT90, FT2. So with the example, you can work on this algorithm and you can see that the maze 2 started from right here, then it goes from here, it go here, it go here, go here, depending on these instructions. See, this is FD4. So do you have the book with you?
I have the virtual version.
Okay, okay. Can you open page number 54 and 55 and go through this maze example and give me a thumbs up so that I can carry on with the 4.2? There are some examples still here. I want you to go through them.
Okay, sir.
In 4.2, this is about the flowchart and the pseudocodes even more. So when it comes to a flowchart is a diagram that uses specific shapes and arrows to produce an algorithm that someone can follow. The pseudocode does not have symbols but structured statements. Like when we are talking about a flowchart, you can see different boxes, different symbols, different colors going here and there. But when it is about flowchart, when it is about a pseudocode, so pseudocode do not have symbols, but only structured statements. So syntax, uh, uh, there is no syntax that it must follow, but it should use keywords as in the flow diagram, such as input and output and so on. So when we are talking about the flowchart structure, so whenever you start a flowchart, so there are some set symbols through a flowchart. So you will be introduced to them in each of the sections. So every time a flowchart ends and the flowchart stops, it do it with a terminator. Like you have a start and the stop box. So what I'm trying to tell you right here is that whenever the flowchart starts and the flowchart ends, it works like this. See, this is this box, this curved box, this circular box, like this shape exactly. This is used to start the flowchart. This is used to stop the flowchart. Any problem in this?
No, sir.
Then the arrow is the flow line when following a flowchart, you can follow the arrows. Algorithm don't go straight from start to stop, so they need input, output, processes, decision, and loop. So when it is about input, it's about putting data into an algorithm. When it is about output, it's about displaying the data. When process is about when you are performing the process to make the changes, and decision is like the comparison. So whenever you are working with the pseudocode, you need to understand that you are actually not using the symbols, but you are using structured English or structured statements. Like there is no specific syntax that it should follow, but it is using the keywords such as input, output, and so on. But when you are talking about the flowchart, so a flowchart have many symbols and many boxes in each of the place, like this start and stop. Then also you have the flow line as well, which is being used when you are following a flow chart. So you follow the arrow. So algorithms don't go straight from start to stop, but they need input, output, process, decision, and loops. So in a flow chart, why do you need input? You need input so that you can put data into an algorithm. You need output so that you can display data from an algorithm to the user. You need process so that an action that is being performed to some data to make the changes. Then you can also have the decision as well, which is being used as a comparison, that is being used to decide if code is being running or not, and loops that is being used that to check if it is being repeated or not. Any confusion in this area?
No, sir.
Okay. Now we are going to discuss about the input and output, and algorithms are often needed to output the message such as the text on the screen to the user, and what is the need to do that, so you can actually see that what action you need to do. So flowchart, this is the first symbol right here. If you want the algorithm to output something to the user, can you tell me in which of the case you want to output something to the user? Why there is a need for that?
To show something, because like to show maybe the result, to show like to communicate with the user.
Okay, okay. Yes.
Like
So,
output should be shown in a way, right?
yes, exactly. Output is shown so that you can actually tell the user that what you need to do, what you need to perform, like this. So, this is the reason that we have the output. So, if you want to output something into the algorithm, so then you need to use this box. Can you see the one right here? So for
Yes, sir.
example, a word, a sentence, or a number. So you will be needing to output it into this box. Can you see this box over here?
Yes, sir.
This is an example of a flowchart. Okay. The first example I told you was how to start that and how to stop that. And now this one for this part, it is how to output that. Like, can you see in the example below that after the word output, you put the text you want to display. If you want output hello world, you will use this. Is this fine?
So,
Is this clear?
so what is the meaning of hello world? Means like,
However, it's just a simple message. They're just showing you an example. I can either output Abdullah is a great student.
okay,
Okay. Okay. Now, notice how the words are being output in a speech mark. So you need to remember one thing is that whenever you are generating the output, so you need to generate the output by putting it into inverted comma. So inverted comma means that exact message will be displayed to you. Is this fine?
yes, sir.
Exact message will be displayed to you. So you need to put the this marks now. Other than that, if you want to input or if you want to read any data, so you are going to use the input command. So with the input command, do you know what happens with the input command? Let's get back here to see the processes. Can you go through them? What is the reason for inputting and outputting the data?
To like putting the data inside an algorithm and output is
Yes,
displayed.
adding as an input so that you can work with it. And the other part is for the output. Okay. When the data is input into an algorithm, it needs to be stored somewhere. So this is actually done using a variable, right? So you can use a variable with a identifier that will give you a space in a computer memory. So you can store the value. So think of variable like a box with a name. Like for example, my number, my variable. Like for example, if I have so many students in my class, I'm going to store all of them into a variable like student's name. So variable names are the identifiers that are going to hold your value. Is it clear?
Yes, sir. Sir, hold your value meaning?
Hmm?
You said hold your value. Like it
Yes,
means it
it's like
contains the value?
yes. It's like it contains the value. Like for example, I have three students in my class, Ali, Abdullah, and Ahmad. So instead of writing Ali, Ahmad, and Abdullah again and again, what I'm going to do is that I'm going to store all the three names into a variable and I'm going to give the variable a name like student's name. So then in later on in the program, instead of writing the three names again and again, what I'm going to do is that I'm just simply going to call out the name of student name and that's it. So this is going to take the three names automatically. You do it in maths as well. Like, for example, 15 is giving to the value of A. What is A? A is a variable, right?
Yes, sir.
So you can see the definition of variable that this is basically a space in the memory of a computer that has an identifier where you can store data and this data can be changed. Is it fine?
Yes, sir.
Then this is how you input the variable with a symbol. So you write input in this box and then you write the variable name. That means any data that has to be entered here is going to be stored here. Then you can put these together with the start and the stop to create a flowchart like this. Any confusion in this part?
No, sir.
Once you have a variable, you can output it at name as well, like this. Okay. So now